We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step. We've all heard the story of humanity's first steps on the moon. But what about our last steps?
This is Gene, and as I take these last steps from the surface, for some time to come, but we believe not too long in the future, America's challenge of today has forged man's destiny of tomorrow.
In December 1972, two astronauts climbed into a small metal capsule and prepared to return to Earth. The Apollo 17 crew included the first scientists to set foot on the moon, and the astronauts spent more than 3 days exploring. They conducted more experiments and examined more of the surface than any previous mission. This concluded the Apollo program. More than 10 years' work by 500,000 men and women. In a competition between the United States and the Soviet Union, known as the space race, humanity proved that we could walk on the moon. When the Apollo 17 astronauts blasted off, most people thought we would return soon. But we didn't. Apollo hardware sits abandoned on the lunar surface for more than 40 years now, relics of another time. For many of us, the space race seems like ancient history. Some people miss the glory days of Apollo's explorations. Others think the missions never even happened. Children who once played at being astronauts have grown up, had children and even grandchildren of their own. Now, the next generation of explorers will make the journey. Before humans venture into space, we send our robotic explorers to help us learn what challenges we will face. These spacecraft act as our eyes and ears in space, helping us find out much more about our nearest neighbor. One of the earliest missions, Ranger 9, sent home thousands of images of the moon's surface in the moments before it deliberately crashed. It gave us the first detailed pictures of mountains and craters, helping us identify good landing sites. The Surveyor landers touched down more gently, while the Rangers had just one job, taking pictures. The Surveyors had robotic shovels and other tools. They performed the first experiments to find out what the moon is made of. Next, we sent rovers. The Soviets landed 2 Lunokhod rovers on the surface, each weighing about the same as a small car. Engineers on Earth drove them by remote control for many kilometers, taking ground-level pictures and testing the moon's soil. Scientists today still study data and samples from these historic missions. But these early visitors mostly told us about the small areas where they touched down. To get a bigger picture, we need to look at the moon from orbit. NASA and the European Space Agency have sent spacecraft to orbit the moon. And recently, China, India, and Japan have done the same. From orbit, these spacecraft have mapped the moon, cataloged chemicals on its surface, and even measured tiny changes in gravity from one place to another. A traveler to the moon experiences a smaller pull of gravity than on Earth. Only 1/6 of what you're feeling right now. A visitor might also be shaken by moonquakes, which can start deep inside the moon. The smaller moon orbits the bigger Earth. One side always faces Earth as it circles once a month. That means most spots on the moon get 2 weeks of daylight, followed by 2 weeks of night. With no atmosphere to trap the sun's heat, temperatures can rise to more than 100 degrees Celsius, then drop to minus 150 degrees Celsius. A visitor to the moon needs to deal with this wide range of temperatures. But not every spot on the moon goes through such extremes. Near the poles, some mountains receive sunlight all the time, and some deep craters always remain in the dark. One spacecraft, called the L-Cross, went on a one-way mission to slam into one of these dark craters. The impact lifted up a cloud of material that had been hidden from the sunlight for billions of years. Inside this cloud, the L-Cross detectors discovered pure, frozen water. Water at the poles can help people to live on the moon. We can drink water, of course, use it for growing food, and also break it down into oxygen and hydrogen. Obviously, we need oxygen to breathe, but we can also use oxygen and hydrogen as rocket fuel. The moon has other resources too, including aluminum, iron, gold, even platinum. These can help us out here on Earth, help us survive on the moon, and help us venture to other worlds and beyond. But the moon lies far from Earth, and governments have spent tens of billions of dollars to travel there. Can we find a better, more economical way? What would motivate people to start a new space race? For centuries, people have created prizes to encourage exploration. In the 18th century, the British government offered a reward to improve navigation and to make ocean voyages safer. Nearly 100 years ago, New York hotel owner Raymond Ortigue offered a prize to the first person to to fly across the Atlantic non-stop. A first step toward creating global commercial airlines. More recently, the Ansari X Prize helped to start a new industry that takes tourists up to the edge of space and back. Such prizes have successfully opened up frontiers of opportunity and changed civilization in unpredicted, innovative ways. So what prize could bring us together to go back to the moon? How can we harness the enthusiasm, resources, and know-how that exist all around the globe? For such a difficult project, you need a big prize and a big vision. The Google Lunar X Prize has inspired people from around the globe to join a new era of lunar exploration. This $30 million competition will stimulate a new generation of engineers, scientists, and entrepreneurs to think about space as a place to do business, to innovate, and to change the world. So, what do you have to do to win the Google Lunar X Prize? The first challenge is to escape the Earth's gravity. The force that keeps us all grounded works against a spacecraft launch. You want to keep your spacecraft small and lightweight, so you spend as little energy as possible fighting Earth's gravity. Once you're off the ground, you need to cross the 400,000 kilometers to the moon. One small miscalculation, and your spacecraft could end up missing the moon entirely. On the way, you need to make course corrections to avoid smacking straight into the lunar surface. To get into lunar orbit or begin your descent to the moon's surface, you need to slow down. Slowing down requires firing engines at exactly the right moment for the right length of time, so you need precise calculations to end up in orbit. Then you need to find some place to land. You probably want to avoid rocky hills and craters and land someplace flat. After making it to the surface, your craft has to either take off again or release a rover or smaller hopper. Then, whether it flies, hops, rolls, or roves, your spacecraft has to travel a distance of 500 meters. To claim the Google Lunar X Prize, you must now initiate your mooncast, take video and pictures, and send them back to Earth so we can all share what your spacecraft can see. But there's one more catch. To win the prize, your team has to be at least 90% privately funded. No governments allowed. That means teams need to keep costs down. If future exploration costs less, we can do more of it. Let's meet people who have taken on the challenge. Over 30 teams from around the globe have entered the competition. Each team has a different approach and unique motivations. One team of students has the opportunity to learn from engineers who worked on the original space race.
I'm Ruben with Team Omega Envoy. We are in Orlando, Florida, and our rover name is Sagan. And the cool thing about Sagan is that students are getting to design the rover, and they're also building it. So they get to send a piece of them to the moon.
During the previous space race, only 2 nations could afford to build rockets. Today, a global industry has made access to space much more affordable.
We are Barcelona Moon Team, and when we were selecting our launcher, we had several options. We had the European Vega, we had the Russian Dnieper, and the American Falcon 9. But we finally selected the Long March 2C, a Chinese launcher, very reliable and cost-effective.
Without government funding, teams have to find ways to raise money. Most teams rely on volunteers from many disciplines.
At SpaceL, we are mostly, well, 95% of us are volunteers, engineers from many fields, aerodynamics, mechanics, and so on. And there's me, I'm a neuroscientist. For the last 10 years, I was studying the brain, how the brain produces movements. In the spacecraft, it's the same. Inputs are getting inside from different sensors, getting processed, and then a command is issued to the engines just instead of the muscles.
Keeping the mass of a spacecraft small reduces the cost of a launch, forcing teams to explore compact and creative designs.
We're Team Angelicum from Chile. Our rover is very small. It will actually have the form of a sphere, and it will travel to the moon in a CubeSat form, 10 centimeters square wise. And then it will, with the help of temperature and the condition of being a memory metal, it will spread out, giving it the form of a dandelion.
After landing, each team's equipment must travel 500 meters, but not all teams intend to do it with a rover.
Penn State Lunar Alliance spacecraft has been designed to be as simple as possible in order to accomplish this mission. No more or less complex than we need to land on the surface of the moon. Since the spacecraft can already fly, take off again and fly 500 meters to a secondary landing site where it's going to take beautiful video and images of the surface of the moon, return them to the Earth for all of us to see, and then Penn State will win the Google Lunar X Prize.
Some of the spacecraft's finely tuned sensors will give us a new look at previous landing sites, perhaps winning the Heritage Bonus Prize in the process.
We're part-time scientists, and with our rover Asimov, we're going to land at the Apollo 17 landing site, and we're going to capture the moon in a resolution that has never been done before. We want to film the place where man last walked on the moon, and we're using two special cameras which are actually capable of seeing much more than the human eye can see. So we can do a lot of science, but also see the moon as it is today.
The Google Lunar X Prize offers an incentive to get to the moon, but many of the teams are investing in technologies that will allow us to stay permanently.
Astrobotic is sending Polaris to the pole of the moon. One of the major challenges is when the sun is out, it's hot. When the sun sets, it's very cold. The cold can get down to liquid nitrogen temperatures, which is many, many, many degrees below zero. We've found technologies and are developing technologies that can survive that night and start up when the sun comes up the next day. And that's a big deal because it changes a surface mission from a 12-day expedition to something that could last Earth years, which is something that hasn't been possible on the surface of the moon yet.
Finally, to compete for the $20 million grand prize, these teams must make their attempt before the competition deadline. Before launch, these teams will have tested each and every component. Every gram must earn its place. They'll run each calculation over and over again. Each team knows they'll only get one chance, one shot at the moon.
5, 4, 3, 2, 1, 0. At 94%, normal throttles, most of the flight out at 4%.
Who will make this daring attempt to win the prize? Which spacecraft will survive the 400,000-kilometer journey? Which team is going to land on the moon?
Connection to lander lost. We still have no status update.
Signal acquired.
We're down safe and on the moon. Well done, guys.
What message will the successful team send home? The first word sent from the lunar surface in more than 4 decades. But the race hasn't ended yet. The spacecraft must travel 500 meters and send back more video and images to win the X Prize. As the spacecraft prepares for the final part of the competition, where will you be? What will you be doing? Will you be cheering on your team? Will your team take the prize?
490 meters. 491. 492. 93. 94. 95. 96. 97. 98. 99.
These tiny robotic spacecraft will lead the way, not just from Earth to the moon, but from the present to the future.
I can't believe how far we had to walk, but we found it.
And still in the same spot where it won the X Prize.
Huh, I thought it would be bigger.
Hey, it had some tough competition to win the prize.
Sometimes smaller is better.
This is so cool. I lost my room. Sarah will be so jealous when she finds out we've been here.
Our robots will lead the way, but they'll soon need humans to help explore our sister world. Future settlements will provide places to live and work, to gather resources that will enrich life on Earth or launch us towards farther destinations.
Okay, Team 3, do you need any assistance?
No, we're good here. Just a minor repair. We'll be done in 5.
Great. We'll check back with you.
Perhaps some of the problems we face here on Earth can find solutions out here, on the moon or elsewhere in space. We can look to the stars with hope and promise. The journey from the present to the future begins with a few short voyages, fueled by humanity's competitive spirit. These expeditions will take us back to the moon. For good.
Y son los mejores. El Team Angelicum va a llegar a la luna.
I would like that Barcelona moon team will reach the moon. Because our own team.
We love the Lunar Alliance because they're bringing Penn State to the moon.
I like the Team Italia because they have something we have nicknamed the yellow tarantula because it kind of looks like a tarantula except it has 6 legs.
We love Team Astronauts!
I think if I was in the competition, I would win.
Back to the moon for good.